Hey guys, and welcome back to another video. For this video, we will be finishing the Math Kangaroo 2020 test for levels 3 and 4 by doing the 5-point problems. So, let's go ahead and get started with number 17. A standard dice has 7 as the sum of the dots on opposite faces. The dice is put on the first square as shown, and then rolls toward the right. When the die gets to the last square, what is the total number of dots on the 3 faces marked with the question marks? So, we know that a standard dice has 7 as the sum of the dots on opposite faces. And then we want to know the 3 faces marked with the question mark. So, let's see and find out how this dots on this rotate. But before we do that, let's figure out the opposite faces. So it says 7 is going to be the sum of the dots on the opposite faces. So, what is plus 1 equals 7? We know 6 plus 1 equals 7. So right now on the bottom face, we have a 6. Now what plus 3 equals 7? Well, we know 4 plus 3 equals 7, so we have a 4 on this face opposite to the 3. But we don't need to find what face is opposite to the 2, because if it keeps rolling this way, notice how the 2 will stay in the same position, and we know 2 will be here because it never rotates in this direction. It never rotates that way, so 2 will never change the way it is. So we know for sure a 2 is going to be here. The only faces we need to worry about is 1, 3, 6, and 4. So when we first rotate it, it's going to be, so I'm going to do it like this. So I'll say B for bottom, which face is at the bottom. Then I'll say T for top. And then I'll say, let's say L for the left face, which is this one, and then R for the right face, which is this one. So after the first turn, when we reach this one, this is number 1, the bottom will now be a 3 since it's rotating this way towards the bottom, making the 1 becoming the right face because it's always going to go to the next one in the pattern. It goes, so after the top comes the right, so 1 will become the right face. And then the top face, 4 will move from the left face to the top face. And finally, 6 will move from the bottom face to the left face. So now we have 3, 4, 6, and 1. So now let's establish a pattern based on this. So we know that it goes, if the rotation is you go from top to the right, to the bottom, to the left. And we notice that there are 4 sequences in this pattern. And we're going to have a total of 5 rotations, as we can see here. 1, 2, 3, 4, 5 rotations before we reach the final one. So we see we go through the top. So whatever starts at the top will move to the right. Then it'll move to the bottom. Then to the left. Then on this number 4, we will have the same pattern again. So, the only rotation will be number 5. That's the last rotation, and it'll just be 3, 4, 6, 1. Because we only made 1 rotation, and after 1 rotation, the bottom face will be 3, which we don't need. The top face will be 4, which we do need. The left face will be 6, which we don't need, and the right face is 1, which we do need. So, if we add this, 4 plus 2 plus 1, we get the sum is 7. So the answer for number 17 is B. Okay, on to number 18. 6 people order 1 scoop of ice cream. They ordered 3 scoops of vanilla, 2 scoops of chocolate, and 1 scoop of lemon. They topped the ice cream with 3 cherries, 2 wafers, and 1 chocolate chip. They use 1 topping on each scoop, and no 2 ice cream desserts are the same. Which of the following combinations is not possible? So a lot of information, so let's first see what it means. So there's 6 people, and they each order only 1 scoop of ice cream. And we also know 3 vanilla, 2 chocolate, and 1 lemon. And there's 3 cherries, 2 wafers, and 1 chocolate. And we want no 2 ice cream desserts to be the same. So if we have a vanilla, we have 3 of them, and each of them need a different topping. So one of them will have a cherry, one of them will have a wafer, and one of them will have a chocolate chip. So we can cross out 1 cherry, 1 wafer, and 1 chocolate chip. Next, we have the chocolate ones. And they have to be different, and we only have cherry and wafers left. So one of them needs to have a cherry, and one of them needs to have the wafer, because they both can't be cherry. So we can now cross off 1 cherry and 1 wafer, leaving the lemon one with a cherry. So now that we got all of our flavors, and with the toppings, let's look at which one of these is impossible and do not appear here. So chocolate with the cherry. We do see a chocolate with a cherry here, so A is not possible. Is possible, so it's not our answer. B, vanilla with a cherry. We see vanilla with the cherry here, so we know B is possible, meaning it's not our answer. C, lemon with the wafer. Lemon is with the cherry, so that means lemon with the wafer is impossible, so our answer is C. But let's just double check that D and E are not our answers. D, chocolate with the wafer. We see chocolate with the wafer right over here, so D is possible, meaning it's not our answer. And E, vanilla with the chocolate chip. We have vanilla with the chocolate chip right over here, so E is possible, meaning it's not our answer. So the answer number 18 is C. Number 19. The queen tries to find out the 3 names of Rumpelstiltskin's wife. She asks her, "Are you called Ado, Lily, Cleo? Are you called Ado, Lily, Laura, Clora? Are you called Abby, Laura, Cleo?" Each time exactly 1 name and its position are right. What is the name of Rumpelstiltskin's wife? So we can start by first looking at the first one. So it says 1 name and its position are right each time. So Adele, Adele, Abby. So only 1 name is right, and since we have Adele twice, we know Abby has to be the first name, because it's the only one that appears once, so that's the only one that can possibly be right. Next, Lily, Laura, Laura. Lily appears once, whereas Laura appears twice. So Laura, it says each time exactly 1 name in its position are right. We see the name appearing 2 times, meaning Lily has to be the answer for the second name. Finally, for the last name, we see Cleo, Cora, Cleo. Cleo appears twice, and Cora appears once, which means Cleo cannot be right, and Cora is her last name. Her last name. So we know the name is Abby, Lily, Cora, which is A. So the answer for number 19 is A. Number 20. The teacher writes the numbers from 1 to 8 on the board. The teacher then covers the numbers with triangles, squares, and a circle. If you have the 4 numbers covered with the triangle, the sum is 10. If you have the 3 numbers covered by the squares, the sum is 20. What is the number covered by the circle? So we know the numbers are from 1 through 8, and there are 4 numbers covering the triangle, and the sum is 10. We already know what the 4 numbers are, because 1 plus 2 plus 3 plus 4 equals 10, and this is the only possible combination that works, because if we were to go like 1 plus 2 plus 3 plus 5 or anything higher than any of these numbers, it would become larger than 10. So the least 4 numbers are the only possibility for what could equal 10. So we know that each triangle 1, 2, 3, and 4. So that means we are left with 5, 6, 7, or 8. And we know 3 of these equals 20. So which 3 of these equal 20? Well, if we have 5, 6, it'll be 11, and we need 9. So we know we don't have 9 in this, so 5 and 6 can never go together. So it's only going to be one of them. What if you have 5 and 7? Well, 5 plus 7 is 12, and 12 plus 8 is 20. So it's gonna not. So the one that's covered by the circle is gonna be the leftover number, which is 6. But let's just double check. What if the only remaining combination, which is 6, 7, 8? What if it's that? So if we add 6 plus 7 plus 8, we get 21, and that is not 20. Therefore, these are covered by the square. not by the circle, meaning that the circle is the only possibility is 6. So the answer number 20 is D. Moving on to number 21. Jane has some drawings of parrots. She wants to color only the head, tail, and wings of the parrot red, blue, or green, so that all the colors are used on each picture. So all 3 colors are used on each picture. She colors one parrot's head red, its wings green, and its tail blue. How many more parrots can she color so that all the parrots are colored differently? So let's list down the first possibility. So the first one she did was R, B, G. But this will not add to our total because it says how many more parrots can she color differently. So RBG is just the first one she did, but when we're counting how many more she can do, we'll start from the one after that. So let's start by rotating B and G. So we have R, G, B. That's another possibility. So now we know that we no longer have R in the first place for any different possibilities. So let's move G to this place. So we can have G, R, B. And we can also rotate the last 2, so it'll be G, B, R. So now we no longer can have G here because we used up all the possibilities with G as the first one as the head. So now we can have blue as the head. Blue, green, red. And once again we can rotate the last 2, so we get blue, red, green. And since there's no more possibilities for what can be in the first one, we now count the amount of red ones, because those are the ones that are how many more she can do. So we have 1, 2, 3, 4, 5. So the answer for number 21 is D. Number 22. Several teams came to the summer kangaroo camp. Each team had 5 or 6 members. There are 43 people in total. How many teams are at this camp? So to solve this, I'm going to list the multiples of 5 and 6, since each team has 5 or 6 members, and there are 43 people in total. So I'm going to find which 2 multiples of 5 and 6 add up to 43, because that's the only way we're going to find out how many teams, because a team can only have 5 or 6 members. So we're going to stop until we reach more than 40. So we have 5, 6, I'm going to list multiples of 5 first. So these are all the possibilities for the multiples of 5. And now I'm going to list the possibilities for the multiple of 6. So 6 I'm just going to put here. 6, 12, 18, 24, 30, 36, and 42. So these are all the possible multiples of each 5 or 6 that are less than 43. So now we must find which 2 multiples add up to 43, because then we know how many teams of 5 or 6 there are. So we know that it cannot be any of the 5 multiples that end with 0, because no multiple of 6 will end in 3, and if we add something with that end in 3 with something that ends in 0, it'll always end in it'll not end in this number that we want, because all the multiples of 6 do not end in 3, and they will never add up to something like 43. So it can only be one of the multiples with 6 with a multiple of 5 that ends in 5. So let's try 5. 43 minus 5 is 38, and none of the multiples of 6 are 38, so it cannot be 5. 15. 43 minus 15 is 28, and none of the multiples of 22 end in, none of the multiples of 6, my bad, none of the multiples of 6 are 28, so it cannot be 15. Now 25. 43 minus 25 is 18, and we see 18 over here, so we know it's going to be 18 and 25. So 18 is a multiple of 6, so let's see how many teams of 6 there are. 18 divided by 6 equals 3. So there's 3 teams of 6. And now we have 25. 25 is a multiple of 5, and 25 divided by 5 equals 5. So 3 teams of 6, 5 teams of 5. So we add 3 plus 6, and we get 9. So the answer for number 22 is, sorry, what am I doing? I'm so sorry. I meant 3 plus 5 equals 8. So the answer for number 22 is D8. Okay, now let's move on to number 23. Which key would be impossible to cut into 3 different figures of 5 shaded squares? 3 different figures of 5 shaded squares, and we want to know which one's impossible. Let's start with A. So I'm going to use a color more visible on black, which is white. So we can cut it here. So we have a figure of 5. Then we can cut it here. So we have 2 more figures of 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have, okay, so it says 3 different figures. So we know this isn't a possibility since these 2 are the same. So is there any other different way we can cut it? Well, we could cut it over here, and then we can cut it over here, and then we get this figure, and then we can cut it over here. And now they're all different, and they all have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So now it's all different, and therefore A is not a possibility. Okay, sorry it's not visible, but yeah, just know A is not a possibility since it's not impossible and it is possible. B. So there's only 2 places we can make a cut for the first one. Actually, no, there's multiple. So the first one is here. And then we can also do one here. But then that would make us forced to make a cut here. And then we can see they're all the same. So this doesn't work. Another place we can make a cut is we can do one over here. And then we would have to make one over here. And then we'd also have to make one over here. But then we notice that these 2 are the same, so it does not work. Next, let's try making a cut over here and over here. So then, if we notice, we have this, we have this, and we have this. And these 2 are once again the same. So we can notice that no matter which combination we try, B is always going to be the same. So, I mean, B will never have 3 different figures of 5 shaded squares. Therefore, the answer number 23 is B. But we can go ahead and double check for the remaining C, D, and E. So for C, we can make one cut here, one cut here, and then one cut here, and you can see they're all different. Next, D. We can make one cut here, and one cut here. And once again, we see there are 5 shaded squares of 3 different figures. So once again, D is possible. And E, we can do one here and one here. And we can see they're all different. So once again, E is possible. So the answer number 23 is B. Okay, the last problem, number 24. Anne replaces letters in the calculation can plus GA minus Ru. Sorry, I had to sneeze. Okay, so can plus ga minus Ru with sum of the numbers from 1 to 9, and then calculates the result. The same letters are replaced by the same number, and different letters by different numbers. What is the largest possible result she can get? So this is the equation, and 1 through 9, and the same numbers, so the same numbers are replaced by the same letters are replaced by the same numbers, and different letters are replaced by different numbers. So if we see can plus GA plus minus Ru, we want the largest possibility. So when we subtract, we want this number to be as small as possible. So the smallest possibility for Ru, because if it's larger, it'll take out more from our sum. So we want it to be as small as possible. So we want R to have the least amount of value, so we want it to have 1. Then O to be the next least, which is 2. And O has to be the same for both of them, so it would be 122. So we can subtract this from whatever KAN plus GAR. So we want K to be the largest value of all since it's the hundreds place. And these are all tens, ones, tens, ones. So we know we want K to be 9. So we have 9, then A. We want A to be the next largest over G because A appears twice. G does not. So A has to be the next largest, not G. even though they're the same place because A appears twice. So we want the next largest after 9, which is 8. Next, we don't want N to be 7. We want G to be 7 since it's a larger place than N, and they're both adding. So we want G to be the next largest which is 7, and A repeats 8 once again. So we're gonna have 8 here since A is already given the value 8, leaving us with just N, and we want to give it the next largest value after 7, which is 6. So we have 986 plus 78 minus 122. So the first step, let's do 986 plus 78 so we get 1064. So now we want to do the next step, and we want to subtract 122 from this. So if we do this, we get 942. Therefore, we know that the largest possible value for can plus GA minus root is going to be D, 942. Therefore, the answer for number 24 is D. So that is all the 5-point problems, and that wraps up the Math Kangaroo 2020 test for levels 3 and 4. Hopefully you guys understood how I solved every problem. And yeah, that's all for this video. Thanks for watching. Bye!